In this video, you will learn how to divide polynomials by using long division and synthetic division, and you'll also learn about the remainder and factor theorem. So beginning with long division of polynomials. Let's say we had the polynomial 2x squared minus 17x minus 38. And let's say we wanted to divide that by 2x plus 3. Well, the process we can use to divide these polynomials is by using the long division process. Now this is comparable to actual long division with real numbers as opposed to with the variables. So the process will be pretty much the same, but it's going to look a little different because we do have the variables in there. So what we do is we see what number goes up here in the top first of all. So we want to figure out what multiplies with 2x to get 2x squared. Well, 2x times x gives you 2x squared, so an x goes up here on the top. And then we can do the next step, which is multiply the x by, and then it's going to be by this entire thing over here, so by 2x and plus 3. So we distribute, so we do x times 2x to get 2x squared, and x times plus 3 to get 3x. So then we can do the next step, which is subtract. When you subtract, the 2x squareds will cancel out, and then we have negative 17x minus 3x, which gives you negative 20x. So be careful with that, because the most common mistake is right there, forgetting that the minus goes to the other term as well. So we have negative 17x minus 3x to get negative 20x. And then the next step with long division is we can bring down this next part, and that is the negative 38. Now once you have this, we can repeat the process. We can see what goes up here at the top by seeing what multiplies with 2x to get negative 20x right here. Well, if we do negative 10 times 2x, that gives you negative 20x. So we put negative 10 up here. We can then multiply negative 10 times this entire left side of 2x plus 3. So negative 10 times 2x is negative 20x, and then negative 10 times 3 is negative 30. So now, next step is we subtract. The negative 20x's will cancel out. And then negative 38 minus negative 30, that becomes a plus 30. And negative 38 plus 30 is negative 8. So now we have finished the process of dividing. This negative 8 is the remainder. And we can take the remainder and write it as a fraction, just like with regular numbers. So we take the remainder, and we write it as a fraction, where we have negative 8 over the 2x plus 3. So this would be your final answer. We have x minus 10 plus, and then negative 8 over 2x plus 3. So what we have done is we have shown that if you take 2x squared minus 17x minus 38 and divide by 2x plus 3, we get this as our answer. But remember with division, okay, we can think of division in reverse as well. We can relate these different things in other ways. So here what we could do is, once we have our answer, we could actually write it out where we can say that 2x squared minus 17x minus 38, that polynomial, equals 2x plus 3 times the x minus 10 plus the remainder. So plus that negative 8 over 2x plus 3. So in other words, what we can say, just in general, is if this polynomial here is p of x, and then over here, this is your divisor, so we'll call this d of x, d for divisor, then that equals the quotient, so q of x, and then plus the remainder. And we'll call the remainder r of x, so r for remainder. So in general, we can say that p of x, the polynomial, is equal to, and we have the divisor, so d of x, times that by x minus 10, which is the quotient, we'll call that q of x, and then plus the remainder, which is r of x. So this is a way that we can relate all these pieces together. And many times this right here is called the division algorithm. So it just shows how everything is related to each other. So that long division process that we just did Okay, that can be used for dividing by any type of polynomial. So in the last example, we were dividing by 2x plus 3, but we could have divided by anything. We could have divided by 2x squared plus 3x minus 4, or any polynomial. All right, so here what we have is another type of division process that we can use, and that's called synthetic division. Now this process has limitations, but it's easier for certain types of division problems. So synthetic division is going to be useful when you're dividing by a binomial with a degree of 1 and without coefficients with the first term. So if you're dividing by things like x minus 4 or x plus 6, things like that, synthetic division will be very useful for. But if you're dividing by things like x squared minus 4, that's not going to work for synthetic division. If we have, let's say, x squared minus 4x plus 3, that's not going to work either because it has 3 terms. The first one will not work because it has the squared with it. And we could do it with things like 2x plus 5, for example, but it's not going to be very pretty with synthetic division because of this coefficient right here. So what we want are things specifically with x plus or minus something. So a binomial with a first degree and with no coefficients in front of the x term. So let's take a look at an example of using this process. Here we have x squared minus 7x plus 10 divided by x minus 1. So what we do is we're just going to be looking at the numbers. So we just take out all the variables and just look at the numbers, the coefficients specifically. So for example, we have 1x squared and we have negative 7x and plus 10. We take the 1, negative 7, and 10, and we write it right here. And then whatever this number is with the x, we take the opposite of that. So if it's a negative 1, we're going to put a positive 1 over here. We kind of section it off like this, and then we can draw a line down here, leaving a space in between this row and the line. So the process of division with synthetic division is as follows. We will always bring down this first term, this first number. You bring it down and write it right here. All right, next what we do from here is we basically just take this number off on the side, and we're going to multiply, and then we're going to add with this negative 7. So from here it's just going to be a process of multiplying and adding, multiplying and adding, multiplying and adding. So we take 1 and multiply it with 1. We write that right here, and then we add. Negative 7 plus 1 gives you negative 6. And then repeat again. This 1 over here you multiply with negative 6, and that gives you negative 6, and then you add. 10 plus negative 6 is positive 4. And that's it. So what we have are the different coefficients and the remainder, and from here we can put in the variable parts. So we started with x squared, and we're dividing by x to the first power. What that means is that your answer is going to have a degree of 1. So it started with the second power. This 1 corresponds with 1x to the first power. Because it was the second power, now it's 1 less than that. And then here this negative 6, that's going to be x to the 0 power, which would be your constant. And this number over here on the side, the far right, is always the remainder. So we take the remainder and we write it as a fraction. We take 4 and write it over our divisor, which was the x minus 1. So your final answer is going to be x minus 6 plus 4 over x minus 1. All right, and that's your process. And by the way, the setup that we have over here, sometimes people will write it a little bit different. Like sometimes people just put like a line right here and then put the 1 off on the side. It doesn't matter, but this 1 is sectioned off away from everything else. Let's take a look at another example. Here we have x squared minus 28 divided by x minus 5. Now this one we got to be careful because right here we are actually missing a term. Notice we have a second power, but we're missing x to the first power. So we have to write that in. And by the way, you'd have to do that also with your long division process. So if you're missing a term like that, make sure you put in a 0 for that. So we take our coefficients. So we take 1, you write it right here. 0, make sure you write that. Then the constant -28 goes over here. And then we take the opposite of -5, which is +5. If it was a +5, you write -5 over here. Section it off, and then you put a line right here. And you keep a little space in between the row and the line. So now we can begin our process. And see if you can do this on your own. So what we do is we would bring down the 1, and then we begin our process of multiplying and adding. So you multiply 5 times 1, write it right here. Then we add. 0 plus 5 gives you 5. Multiply and add again. 5 times 5 is 25. Add that with -28. That gives you -3. So we have everything that we need to now fill in the variable parts. We started with x squared, which means the 1 goes with x to the first power. This 5 is going to be your constant, and this -3 over here is your remainder. So we write that as a fraction, so plus -3 over, and we divide by this x minus 5, your divisor. So your final answer is x plus 5. You don't need to write the coefficient or the exponent. So x plus 5 plus -3 over x minus 5. We'll get a little more practice with synthetic division, but we want to talk about what we call the remainder theorem. So this remainder theorem, what it says is that if a polynomial p of x is divided by x minus c, then the remainder is p of c. So what does that mean? Well, let's take a look at an example. Let's say we want to evaluate x cubed plus 3x squared plus 2x plus 8 at x equals -3. So the normal way of doing this would be you plug in a -3 in place of x. So if this is your p of x function, p of x equals this, you plug in -3 in place of x. So what we're going to get is -3 cubed plus 3 times -3 squared plus 2 times -3 plus 8. And that would give you -27. -3 squared is positive 9 times 3. That gives you positive 27. 2 times -3 is -6 plus 8. So -27 plus 27 would cancel. -6 plus 8 would give you a positive 2. So that's nothing new. We've done this before. You've plugged in numbers before and evaluated. But what this remainder theorem says is that if we do synthetic division, or if we just divide, where you divide by x plus 3, we're going to get the same remainder. The remainder is going to be the same as this number over here. So when you divide by x plus 3, remember you take the opposite of that with synthetic division and you put it over here. And then you take the coefficients. You have 1, 3, 2, and 8. So you put that right here. And if you go through the synthetic division process like this, what you're going to find is the remainder is going to equal 2. Well, let's verify that. Let's bring down this 1 and begin our process. So we do -3 times 1 to get -3. Then we add. 3 plus -3 is 0. Then we multiply and add again. -3 times 0 is 0. And then add 2 plus 0 to get 2. Multiply and add again. -3 times 2 is -6. Then we add with 8 to get positive 2. So if you write this out with the variables put in there, we started with x cubed, which means that this 1 corresponds with 1x squared. So whatever the degree was to begin with, we decrease it by 1. So we have x squared plus 0x, and then plus 2, that's your constant. And then this here is your remainder. So plus 2 over, and then we divide it by x plus 3. All right, so we don't need to write the 0x, we just write x squared plus 2 over x plus 3. So all that to say that the remainder is 2. So the remainder is 2, which was the same as plugging in -3 and evaluating. So what this does for us is two different things. One is that if you wanted to evaluate quickly, So if you wanted to plug in this negative 3 right here in place of x, sometimes it's going to be a large number, and it's going to be a pain to have to evaluate and calculate everything. So what you could do instead of evaluating, is you could use synthetic division and find the remainder. The remainder is the same thing as when you plug in negative 3 in place of x. And the other way around, if you wanted to find the remainder quickly, you can do that, where instead of doing synthetic division, what you could do is just plug in the negative 3 in place of x to get the remainder. So it can go both ways depending on what you're trying to accomplish. So that is your remainder theorem. And we also have what's called the factor theorem. So the factor theorem says that a polynomial p of x has a factor x minus c if and only if p of c equals 0. So let me explain that in common English. All right, so if you, for example, were to take 8 divided by 4, all right, well, 4 is a factor of 8, right? 4 is a factor of 8 because we know that when you divide, we get 2 with no remainder, right? There's no remainder. But if you divide it by 5, we know that 5 is not a factor of 8 because when you divide, you're going to get 1 with a remainder of 3. So we know that 5 is not a factor of 8 because there's a remainder, whereas 4 is a factor of 8 because the remainder is 0. And that's really what this factor theorem is all about. We know something is a factor if and only if the remainder is 0. And remember, from the remainder theorem, the remainder is the same as p of whatever you plug in. All right, so it's the same thing. And another way of expressing this is that x minus c is a factor of p of x if and only if c is a 0 of p. Now let's explain this with an actual example. All right, let's say we had x minus 3, and we're trying to determine if x minus 3 is a factor of 2x cubed minus 3x squared minus 10x plus 3. Well, all we need to know is what is the remainder when you divide. So two ways we can do this. You could plug in the opposite of negative 3, which is a positive 3. You could plug it in place of x to find the remainder, as we discussed in the previous slide. Or we could go through synthetic division and see what is the remainder as well. So either is fine, we get the same end result. All we need is the remainder one way or another. So let's do synthetic division because that's still a little new for you. So you take the opposite of negative 3, which is positive 3. You take the coefficients. We have 2, negative 3, negative 10, and then a positive 3. And then what we do is we can then bring down this first number, and then we multiply and add over and over again. So we multiply 3 times 2 to get 6, and then add. 6 plus negative 3 is positive 3. Multiply and add again. 3 times 3 is 9, then add with negative 10 to get negative 1. Multiply and add again. 3 times negative 1 is negative 3. Add that with 3, that gives you 0. So this number here, that is your remainder. So because the remainder is 0, what that means is that yes, x minus 3 is a factor of the polynomial 2x cubed minus 3x squared minus 10x plus 3. And in this example, okay, this number here, the 3 is like your c value. So see up here it says polynomial p of x has a factor of x minus c if and only if p of c is 0. So in this example, we had x minus 3. So c was your 3. Okay, x minus 3, x minus c, same thing. So c was 3. And we have verified that p of c is equal to 0. The remainder is 0. And we also can conclude in this next line that because x minus c is a factor, x minus 3 is a factor of this polynomial, then c is a 0 of p. So meaning you have a 0 at 3. So the 0 meaning that it's going to be your x-intercept. So it's going to cross over this polynomial. It's going to cross over the x-axis at the point of 3, 0. And that can be useful as well for finding the intercepts. And we'll do more of that in the next lesson. Now, one last thing to discuss, and that is what we call a reduced polynomial. So what a reduced polynomial is a factor of a polynomial that is 1 degree less than the original polynomial. So it's kind of like the same idea as reducing a fraction with actual numbers. Right? If you had 8 divided by 4, we can reduce that, right? So we reduce it by dividing. Same idea here with the polynomial. We can create a reduced polynomial by dividing. And it's going to be 1 degree less than the original polynomial. So what does that look like? Well, here we have an example. We have this polynomial divided by x minus 3. So here what we can do is we can divide, and we can do our synthetic division process. So we take the coefficients of 10, negative 22, negative 17, and negative 21, and then we write them right here. And then we take the opposite of negative 3, which is a positive 3, and you section it off over here. Then you draw a line, and then we can begin our process, where we can bring down this first number, we bring down the 10, and then we write it right here. And then we can begin our multiplying and adding process. So we multiply the 3 times the 10, that gives you 30, and then add with negative 22 to get positive 8. Multiply and add again. 3 times 8 is 24, and then 24 plus negative 17 is positive 7. And then we multiply and add again. 3 times 7 is 21, negative 21 plus 21 is 0. So we started with x cubed, which means the 10 corresponds with x squared. The 8 corresponds with x to the first power. The 7 is your constant, and 0 is your remainder. So your answer when you divide is 10x squared plus 8x plus 7. And we can say that that polynomial is a reduced polynomial. We took our original polynomial and we divided it. And we notice it fits our definition, where we have a factor of our original polynomial, and it's 1 degree less than the original. So we started with x cubed, now we have x squared. And this can be helpful, by the way, if you're trying to get a factor further. So you divide by like x minus 3, and then sometimes what we have here could even be taken further and simplified even more. And we can use that to find the intercepts. All right, one more thing I should mention. When you're filling in for the synthetic division, if you are missing something, we said to put in a 0. Like if you're missing an x squared or an x in between terms, you put in 0. But we also need to do that if you're missing the constant. So if there was no negative 21 here, you have to fill that in with a 0 right here because the constant is missing. So that's just one little side note to be aware of. And that concludes our lesson for today. We will see you next time.